good because it will give you the exact answer, like even to the decimals. Okay. If you're graphing by hand, you saw with those two, if it doesn't hit at a nice spot, you have to estimate. So this would be a case, and you don't have to graph this, and it's not on your notes. But sometimes it's difficult to identify the exact solution to a system by graphing. Okay, if I graph one line, another line. Okay, so we have other methods to solve systems. Because if you take a look at this one, 2x minus 1 has a y-intercept of -1 up to over 1. That is the black line. The red line is -1/3 x plus 2. At positive 2, I go down 1 over 3. This is where they hit. They clearly hit. But is that it? Like, are those whole number points? No. You'd have to estimate. Okay. From where you can see, what would you estimate that answer to be? Okay. From where you see, Jenna, come on, give me an estimate.
1.5, 1.5.
Okay, that's close. Okay, well, we don't know for sure, do it. So 1.5 would be a halfway over. So I'd say maybe not quite 1.5, but I'd have to take that answer because I don't know for sure. So we're going to do another method. We call it substitution. Okay, we call it substitution. Well, what do you think of when you think of substitution? If there's a substitute teacher, there's somebody in here for me, right? Replaces me. So can you substitute 2 4/4 for $1? Right, they're equal, right? It has to be equal. So take a look at this. Here's your 3 steps. Solve one of the equations for one of the variables. Okay, so basically you need to get x or y by itself. Substitute the expression from step 1 into the other equation. Okay, and solve for the other variable. And then substitute that back into the original. Now that's going to be a little confusing until we go through a step 1. So take a look at number or letter A there, the first one. All right. When we're solving a system, we're looking for any ordered pairs that work for both equations, right? We could graph those. Okay, that still works, but sometimes it's not the best. Algebraically, sometimes works better. All right. According to the first equation, ignore the second one for right now. Y equals what? Everywhere there's a y, what could you take out and put in its place? Think about this. Everywhere there's a y, what can we take out and put in its place? What's that?
A 1.
Not a 1. It says y equals what?
3.
3 what?
3x.
3x. Y is the same as 3x. Y is the same as 3x. So, think about this. What can I put in for that y? What can I take out and put in for that y? Jeff? You're kind of lost in the sauce here. Yeah. Austin?
Would it be the 3?
Not just the 3, but the 3x. Y equals 3x. So take this y out and put 3x in its spot. Okay, see what I did there? I took that y out and I put 3x in its spot. Why in the heck is that useful? Take a look at that equation. Go back to what we know. Can we figure out what x is? Solve for x. Yeah, we're going to go back to our old ways. Subtract x. 3x minus x is 2x equals -2. Divide by 2. Now I get -1. Now the answer to a system has to be an ordered pair. You still have to go back and figure out what y is. I know what x is. How do you think I figure out what y is? Okay. Now we're going to use the same idea. X equals what? Okay. Maya, what's x equal? It's right there at the bottom.
-1.
Yeah. X is the same as -1. So everywhere there's an x, what can I put in its spot? Yeah, we've done this millions of times. So all right, it says y equals 3 times x, right? Well, if x equals -1, this means y equals 3 times -1, which is what? -3. All right, what's our answer? What's our final answer to this whole problem? Okay, McGavin, do you know how I write? Maybe I should word it that way. How do I write my final answer?
Just -1, -3.
Good. You write it as a point. You write it as an ordered pair. So Jeff, my answer is -1, -3.
Hey
If
guys, you're doing your homework tonight, right? You should have your computer open to your what? What calculator? Now, you still have to show this work, right? So you get an answer. So what can you do right now? You can put in y equals 3x, and then y equals 2, or excuse me, x minus 2, and you can see what? If you are right. But you still have to show your substitution work. That doesn't mean you use your decimals to get the answer, it means to check your answer. And this is what you can do on the test,
Okay.
the state test.
So here's my work. Here, over there, I just typed it into Desmos. Make sure you hover over where they hit, and it says -1, -3. Okay, no, I'm right. Okay, no, I'm right. So you got your Desmos, boom, you plug it in, you check it. But you got to be able to do this. That's not a substitute for substitution. I didn't mean to do that. Is that a pun? Would that be a
That'd
pun?
be a good one. Yeah.
Okay, I'm not sure. I'm not up on my English. Okay. All right, second one. Now, they're not all the same.
Should I go?
Yeah, you should go.
Okay, what's the homework?
What is the homework? The homework is those problems. Write those down. Ellie has to leave. She has an appointment.
Are you recording this?
Reese was on it.
Yeah, boy,
Reese was on it. He's like, "Are you recording?" Okay. What's your favorite candy, Reese's cups? No. What's your favorite candy? Twix. Oh, you ever have a
Which
what?
one? Left one or right one?
Uh,
It's just this commercial.
right to voice.
It's the same thing. Just,
Do you ever have a
you never see those
whatchamacallit?
commercials?
Yeah, oh yeah. You ever have a whatchamacallit?
Who likes the left switch?
It's a commercial. What's better, left or right?
Have you ever had
They're
a
arguing.
whatchamacallit?
They're both the same. How?
likes the left.
It's a real candy bar.
How's the right one?
Has anybody ever had a whatchamacallit?
It's right.
Yeah. I asked Reese, it was his favorite. Ever had a whatchamacallit? He thought I was being
A what am I call it?
a goofball.
Here, take a break.
Oh,
It's
All right, guys. Here's what we want to do here, guys. What I like to do on these problems right here is I like to get my ordered pair ready. That tells me what I need to write an ordered pair. So write an ordered pair bracket up there, so that's ready to go. Now, what I look for is one of them solve for x or y. It doesn't have to be y; it could be x. And see how the top one is y equals something? You guys see that? So that's part of our work. It's done for us. So box that in right there. Box that in. Okay? So I'm going to replace that. It says y equals this. Well, down here, I can replace that y with x plus 1. All right? My goal is to get rid of either the y or the x so I can solve for one of the variables, right? Okay, so I'm going to replace it. 4x plus what? Well, x plus 1. There we go. Do you guys see now we just have x, right? So I can solve for x. Okay? So now, guys, once we do this step, this should be reviewed. Okay, we've worked on solving equations, right? Okay, how do I simplify this side? What am I going to do? Go ahead, Maya. Yeah. No, it's on the same side. We're combining like terms.
Oh.
So you have to add them, right?
Yeah.
So what do I got?
4x
Plus,
plus x.
which is,
Um,
what's 4 plus 1?
5.
5x. Okay, now what? What do you think? Lindsay, what do I do now?
Would you subtract 1?
I would. And what do you got?
Equals 5.
All right. Reese, finish it off for us.
Divide by 5 and then you get 1.
X equals 1. Guys, halfway, I think that's the hardest one to get the first one. Okay, once we get the first one, the second one shouldn't be as bad. Okay, guys, we're gonna have to solve probably for a letter here in a couple coming up. I'm gonna take my answer, and I want to always. I think it's probably easiest to put it in the one we use for substitution because usually it's solved for the other one we have to get. So I'm gonna put this equation right here, and I'm gonna sub in. I need to get y. I need to sub in 1 for my x because that's what x equals. I mean, this one was a very simple one. Obviously, 1 plus 1 is 2. And if we put that in Desmos, put these 2 in, they're either going to hit at 1, 2. Okay, they're going to hit at 1, 2. Substitution, putting something in for something else. All right. Now, why is this one going to take more work, a little bit more? Just a little extra step. Do you guys see it? Why? Go ahead.
You have to get y by itself.
Okay, we can, or look up top. Do you see how x has 1 in front of it, right? Wouldn't it make sense to get x by itself? Wouldn't that be the easiest thing to do? Does everybody agree? Okay, so let's take that first equation, guys. Let's take this first equation and just write it down here. Like that. Since x doesn't have a number in front of it except 1, it's pretty easy to get it by itself. How can I get x by itself? What am I going to do here? Go ahead.
Subtract the x.
No. I don't want to do that because then I have to get the 11 over this. I can do it in one step.
Oh, did you subtract the 6y?
Nice job. I want to do this. Now, be careful for the love of humanity. Guys, these aren't like terms. Don't put them together. Don't go like 5y. They're not like terms. Now, we had to do that. Now I got what? Wherever I see x in this equation, I can substitute what, guys? Negative 6y plus 11. Do you guys see that? Now, before I go on, we're going to substitute this right here, right? Okay, what's going on between the 2 and the x? Multiplication. So here's where you have to be very, very careful. Do you guys see how this is one chunk, right? This whole thing is going in for x. So let's write this right here, guys. 2x plus 3y equals negative 5. Write that on your paper. You guys should be doing this, organize it just like I'm doing it. Okay, I'm going to put this whole chunk in. So that means this whole thing is being multiplied by 2. Okay? Now, once we put that in there, that's the hardest thing to remember. Now we have to do what with that 2 to the parentheses, guys? What do we have to do? What's it called?
Distribute.
Thank you. Let's distribute. Dinah, go ahead, hon. Distribute the 2 for me. What do you got?
Negative 12y.
Keep going.
Right.
Plus.
Plus 22.
Okay, plus.
What do you just put 3y down?
Yeah. Equals.
Negative 5.
There you go. Now, a lot of work so far. Okay. Addie, what do I do now? What do I got to do on the left?
You combine the negative 12y and 4y.
Nice job. Combine like terms. Guys, they're on the same side of the equal sign, right? Combine them how they are. Addie, what do you got? What's negative 12 plus 3?
Negative 5.
Okay. Now what? Miss Pixler, what do I do now?
Subtract 22.
Nice job. What do you got? Negative 9y equals.
Negative 27.
Thank you. Emily, what do I do now?
You divide negative 9 on both sides.
And what do you got? Now, guys, see how you have your empty coordinate point ready to go? As soon as I get an answer, I like to plug it in right there. Okay? Now, guys, pay attention. This will save you a lot of work, I think. Do you see all the work we did? It wasn't that much. But do you see the work we did to get this by itself? Don't we have to get x yet? Does everybody agree? So why not use that work we did and plug what we got for y in right here so that way it's already solved for x. Does that make sense? It'll save us a little bit of work. So let's use this right here, and we're going to put, instead of this y, we're going to put 3. So I'm going to go x equals negative 6 times y. Well, what's y? 3. I think it saves your work and time. Okay, what do I do? Simplify it. What do you do, Reese?
Times negative 6 by 3.
What do you got?
Negative 18.
Plus,
11.
what do you got?
Negative 9.
No. You can think of it, it's going to be negative. What's, if I subtract those, what's 18 minus 11?
I can't do quick.
Well, you got your calculator right next to you.
Negative 7.
Now, guys, you see all the work we had to do? This was a lot of work, okay? But on a test or quiz, well, we're not going to be able to have your computers out on the test. But on the state test, what can you do? On your homework, what can you do? Plug these two equations in just how they are into Desmos, and you should get what for an intersection? You should get negative 7,3 for the intersection point. Okay? How you guys doing with this? Okay, let's look at this one right here now. Do you see one of the variables with a 1 out in front? Which one is it? The top one? So what are we going to solve for? What do we want to solve that top equation for? Anybody? Y. We want to solve this one for y because it's the easiest thing to do. So let's write this right here. Okay, one step. How do I solve for y, Taryn? How do I solve that for y? Thank you. Does everybody agree? Plus 2x. Cross out. Y equals. Are these like terms, Austin? Can I put them together?
Yeah.
Ah,
Oh, no.
so what do I write?
2x plus 8.
Thank you. Now, guys, this is golden for a couple reasons. Remember this. I put a box around it. Okay? Because I'm going to come back to this when I get x and put this in to get y. This situation right here. So we're going to use this again. All right, so now I have this for y. I want to put that in my other equation right there. What's going on with the 2 and the y? They're what? Being what, guys? Multiplied. So just remember, put that in as a chunk. In other words, put parentheses around it. So let's rewrite this. So I got 3x plus 2y equals 9, right? Okay, I'm going to put my 2x plus 8 right here. 3x plus 2 times what? 2x plus 8 equals 9. Okay, why don't you guys simplify that really quick? See how you guys do. Simplify that, distribute the 2, combine like terms. You guys go ahead and solve for x. See how you do. I'll just kind of work here. Is everybody okay with that after I distribute the 2? Everybody good? Lucas, what do you think now?
You combine 3x and 4.
What do you got?
7x plus 16 equals 9.
Okay. Good. Jenna, go.
Subtract 16.
What do you got?
7x equals negative 7.
Keep going. You're on fire.
Divide by 7.
What do you got?
X equals negative 1.
Guys, the hard part's done. The hard part's done. Now, remember we boxed in? Remember we worked to get y equals 2x plus 8? We're going to use that again. We need to get y, right? So why not use where we solved this equation? We got it ready for y. Okay, we got it ready. So I'm going to take this 1 and I'm going to put it right here. So y equals, instead of 2 times x, it's 2 times what? Oh, that should be negative 1, right? Yep. 2 times negative 1 plus 8. Okay? Juan, what do you do, brother? What do you got? Okay, keep going. Now, what would you do tonight on your homework? Do what with your computer? Put those both in Desmos, and you should get what for the intersection? Negative 1/6. Okay? Negative 1/6. All right. You guys got this one? All right. One cable television provider has a setup of 60 fee and 80 per month. Okay? $60, 80 per month. Okay, so in how many months will the cost be the same? The other one has what? So we'll do this one. $80 or $60 plus what? 80 per month. What's the other one charge? $160 equipment fee, and how much per month? Okay, it says in how many months will the cost be the same? So we have to set them what to each other? Okay, let's just figure out. Okay, here let's do the cost for, this is company number 1, right? What's the cost? 60 to set up plus what? Plus what, guys? Okay, what do I need to, what's going to keep repeating every month? How much money? That's where that goes then. That's the cost that keeps hitting every month, not the 60. Because that was the setup fee. Okay, company number 2, what's my cost? Well, what do I got? What's my setup? Or this, they call it equipment fee. What is it? $160. How much do they charge per month? Okay, there's our 2 equations for the cost of each company, right? Now, it says, the question is, how many months will the cost be the same? Well, guys, can I just put this right here, set them equal to each other, solve for M. That'll tell me how many months it would be for the same cost. So that's what we're going to do. So I'm going to go 60 plus 80M equals 160 plus 70M. There you go. Now, we have a variable on both sides, right? What was always our rule? Subtract the one that is what? Smaller to keep our M positive. We don't have to, but that's kind of what we did. So what's a smaller M here, guys? 80 or 70? Okay, let's subtract that from both sides. Let's do this. Okay, so I got 60 plus what, guys? 10M equals 160. Now what do I do? What do you think? Yes, sir.
Subtract 60.
Thank you, sir. By the way, start turning your homework in. We got what? 10M equals Hondo. Right? Lindsay, what do I do now?
Could you divide it by both sides?
Yes, ma'am. What do you got?
M equals 10.
Now, what does this mean? What does this mean? M equals 10. What does M mean? At 10 months, what?
10 months, it will be the same cost.
Write that. The cost would be the same for both. I know I'm writing sloppy. Companies at 10 months.
Wait, Jeff.
Couldn't you just subtract the 80 and the 70 just right from the beginning and get the same answer?
No, that's just coincidence. Okay. No, that wouldn't necessarily work.
No. That won't.
That's just,
Now, are we done? What's it want? What would that cost me? Now, guys, we have two equations here, right, to get the cost. Does it matter which one we pick? No, they'll both be the same. So, which one you want to use? You want to use one or two? Doesn't matter. One? Okay. What's M? We're going to put 10 in there for 10 months, right? So let's use this one. Cost equals 60 plus 80M. Well, M is 10. Cost is going to be 60 plus 80 times what, guys? Now, for the love of humanity. Oh, I put 100. Listen, for the love of humanity, you should not use your calculator for this. Okay? Guys, what's 80 plus 10? Plus 60. There's your cost for 10 months. On either system, either company, Either company, $860 would be the cost. Guys, if you were going to live in a place for 9 months, what company would you choose?
Hey, go to the next one.
What?
You'll see.
So it's asking that? Oh. Guys, if you were going to live for 6 months, which one would be a cheaper option? Okay, we know at 10 months they'd be the same, right? Which one would be cheaper at 6 months? What do you guys think?
The first one?
Why? I agree with you.
Because it's just because it's cheaper until 10 months.
Because of the startup, right? That's $100 difference, right? Now, could you check it? What's 8 times 6? Everybody do this real quick. What's 80 times 6? 480 plus 60. Guys, everybody has a calculator. You shouldn't be staring at me. It's 540 for 6 months here. What about this one? So 540. What about this one? What's 70 times 6? Plus 160. Jeff, you were right. Jeff, you were right. First one. All right.
Make sure you put option one. Option one. So make sure you write your answer down. Option one would be cheaper for 6 months. Okay, or company one, however you do that. So, and then next slide, homework.
Settle down. Here's your homework, guys.